Have you all wondered what is the extremum point? So, let me tell you guys what about it. In calculus, understanding the behavior of functions involves identifying key points where the function changes in significant ways. Two such critical points are extremum points and inflection points. Extremum point refers to a location on a graph where a function reaches a peak or a true. These points can be further classified into a local maxima and local minima. Other than that, local minimum is where the function goes to a low point with a particular interval lower than any nearby values. To sum up, the extremum point helps to identify if the function reaches to the highest or the lowest values. What is exactly inflection point? Inflection point are where the point of the curve at which change in the direction of a curvature occur. That means the function will switches from curving upwards, concave up, to curving downwards, concave down. Inflection points occur where the second derivative is close to zero or is undefined, indicating a potential change in concavity. By verifying that the sign of the second derivative changes around these points, one can confirm the presence of an inflection point.
We use extremum point and inflection point to analyze and optimize function, predict behavior, and make informed decisions. Extremum point also help to identify optimal condition and stability, while inflection point provide insight into change in trends and behavior. For step solving, in polynomial, we usually have 5 types of questions. Firstly, find x-intercept or y-intercept. Second, find critical point. Third, find the interval where function x is decreased or increased. Fourth, find the interval where function x is concave up or concave down. And lastly, sketch the graph. Firstly, for finding x-intercept or y-intercept, we usually need to find the value of y by replacing value of x equal to 0, so that after we get the value of y, we could replace the value of y in the functions. For critical point or stationary point, first we need to find first derivative and then set the f prime equals to 0 and then solve the x, then find the related value of y, and then lastly we need to concave the point. To find interval where fx is increased or decreased, we reuse the first derivative and critical point of x and we create the table to check f prime at a chosen point and write a conclusion. To find interval where fx is concave up or concave down, we need to do second derivative by reusing the first derivative and set it equals to 0 and solve the x. And find the related of y, create the table and check f prime x and write the conclusions and determine the inflection point.
In these questions, given a functions fx equals to 2x cubed minus 12x squared plus 18x, find the x-intercept of f. Firstly, we value y equals to 0 and insert the value in the functions. Then we simplify the functions and factorize the functions, and we use quadratic functions to get a value of x. And we get x equals to 0 and x equals to 3. So first point we get x equals to 3 and y equals to 0. And when we insert the value of x equals to 0 in the function, we got y equals to 0 also.
Okay, for B, find the critical point of f.
First,
First, we need to write down the actual equation 2x to the power of 3 minus 12x to the power of 2 plus 18x.
equal to 0.
First, we need to do a first derivative. That will be 6x to the power of 2 minus 24x
when the x
plus
is 3. So
18.
write down the equation and then just replace the x
0
with
equal
3,
to
and
6x
we will
to the
get
power
0.
of 2
For second
minus
y, we need
24x plus 18.
to find the second y
And then we'll need
x
to
will be 1.
expand the equation.
So write
That will
same
be
equation,
x
just
minus 3.
replace the
x
x with 1,
minus
you will
1.
get 8. So the final
The x will
critical
be
point of
3
f
and the other x will be
3, 0,
1.
Find the interval where f is increased or decreased. Firstly, we use the functions to do the first derivative, and the first derivative we got 6x squared minus 24x plus 18. Then we do the table and we use critical point as our guideline, and then we took some of the chosen point such as -1, 2 and 4. And for -1 we got positive, so it's increased, and for value of 2 we got negative and it's decreased, and value of 4 is positive, so it is increased.
For the next question, find the intervals where f is concave up or concave down. Hence, determine the inflection point of f if any. So first step, we need to find the second derivative. As we know, we got the first derivative, which is 6x squared minus 24x plus 18. And for the second derivative, is a 12x minus 24. Next, we need to find value of x. So, x minus 2 equal to 0. So the answer for the x is a 2. Next, draw a number line, and that's how they look. And the third step, make a second derivative table, which is contain 3 things. So for the first thing is interval, the second one is test value, and the lastly is second derivative, which is 12x minus 24. So for the first table, we used 2 infinity and used 3 as a test value, and we got positive. And for second table, we write negative infinity 2, and we use 1 to test value, and we got negative. So to conclude, the answer for concave up is 2 infinity, and the answer for concave down is negative infinity 2. To get inflection point when x equal to 2, to get y, we need to enter the value of x, which is 2, to the equation, which is 2x power of 3 minus 12x squared plus 18x, and the answer for the y is 4. So the inflection point is a 2, 4. For the last question, sketch the graph of f using the above information. So first step, we need to draw y-axis and also x-axis, and write a value for y-axis, same with a x-axis, and plot the maximum point, which is 1, 8, the inflection point 2, 4, and lastly minimum point 3, 0, and connect the lines of the plotted points, and that's the answer for the graph.
In conclusion, we know that differentiation is a crucial tool in a calculus that enables us to determine the rate at which a function changes. The derivative of a function provides us with valuable information about its behavior at any point in its domain. The derivative can tell us if the function is increasing or decreasing, whether it has any maximum or minimum, and much more. So the concept of differentiation has application in various fields, including physics, engineering, economics, and many others. For example, in physics, allow us to determine the rate of change. For instance, it allows us to determine the rate of change of velocity with respect to time to give the acceleration. Another example, in economic, differentiation allows us to study functional relationship between economic variables. Also, used to analyze marginal costs and revenue functions.